Yeah. So, Daniel, I remember when I lived in Australia, this is, I guess, back in 2005 to 2008, like 3.5 years. You and your family was maybe, you were the most recurring guest we had, our house pet. So you did a lot of trips back then, back and forth from Sweden to Australia. And I remember one particular globe-trotting event that beats everything. You know, like one travel you did that was insane. What was that all about?
Well, Henrik, yeah, I frequented you a lot. I think the record was 8 times in 1 year. Yeah. From Sweden to Australia.
8 times to Australia in 1 year.
Yeah. So you can imagine how much time I spent at home and how popular that was. But I think the occasion you're thinking about is being a very dedicated product manager working at Ericsson and having a Australian customer, in this case Telstra, the large telecom incumbent.
Yeah. So it's like Telia, but in Australia, you could say, the incumbent huge.
Yes,
Telstra.
yes. And at the time, they were doing the transformation from a public entity to a more private-oriented, and they had brought in an American management team. So
I remember this.
Yeah. So
what was his name?
Sol Trujero.
Sol Trujero.
And his 3 amigos.
Yeah, the 3 amigos. And this is, in Australia, this was, in the industry, the 3 amigos was a known term of fear.
Yes, and Ericsson, or myself in form of Ericsson employee, had made, we had signed a deal that we were going to supply a product to them, and it was late. And of course, the American management style is escalate. So the phones rang in Stockholm, and it trickled down to me, and they said, you have to get on a plane and go to Australia and explain the situation and why haven't we delivered? And I said, oh, God. But I did better than that. I actually, the factory where we were supposed to produce the product, I was checking. So we were close. We were close. So I decided to go to the factory and pick up six early prototypes of the product and bring with me. So I had this interesting trip where I went for this escalation meeting in Melbourne then with Telstra. So I left Stockholm, went to London, went to Warsaw, went to Bucharest, went to Timisoara, because that's where the
factory was in Timisoara. Romania. So where are we now? Romania, right?
Romania. Okay. So just getting there, 5 flights. Maybe
flight shame was not on the table in this time.
No, it was just try to get there and get things done. And I spent 2 days there, so I just went to the factory and said, I'm not leaving here until you have 6 prototypes for me here that I can bring with me. So I sat at the factory, and it's a good experience. I think anybody who's passionate about their products or want to put some pressure on their suppliers should try that.
Go and sit in the factory and just wait until they come out with a unit.
Because they're not very comfortable having somebody else there. So I mean, I think it does speed up things when you do something like that, for sure. To make matters worse, I came down with a fever as well when I was here. So I wasn't at my best, and I got some dodgy Romanian
food or whatever
pills to take my fever down. So finally, but anyway, I get the prototypes. I get on a plane at Timisoara this time. Timisoara, Vienna, London, Kuala Lumpur, Sydney, and bang,
Melbourne.
Here I am, Melbourne. Quite confused. The whole trip lasts a week, so I was 2 days in Romania. So from when I started, so I've seeing I was semi-sick. I'd already lost sort of kind of track what day it is, but I think I arrived on a Wednesday morning in Melbourne.
And then more or less like 1 or 2 days in Melbourne max.
No, the next day I had to leave. So there were two meetings. There was a meeting with their technical staff, where I sort of put up all the prototypes for them and sort of
demoed it, or what did you do?
Well, demoed it. We had a long discussion, explained the importance of timelines, this, that, and the other, and they actually unpacked one and had a look at it and inserted a SIM into it and connected a phone and just checked and see, yeah, it kind of works. And the funny thing, what happened during this meeting, because he'd used his SIM card from his ordinary cell phone, and during the meeting, the phone actually rang. So the thing worked.
The prototype
worked, and he answered phone, and everything worked. After that, there was no more discussion. So that was a magic moment in
so bottom line, right? You know, when you're a product manager, this is cool stuff.
Yes, it's kind of. They were super happy. The tech guys. It actually does work. You know, in the meeting, it was proven without.
And was this the very first batch that you delivered?
Very first batch. No, they've never tried it before, and we hadn't actually 100% tried them either. I mean, there were stuff in the lab that were.
Yeah, and what is this product, by the way?
It was called a fixed wireless terminal. It's really to substitute a home broadband and phone connection. It was something that in the early 2000s, a lot of telcos were looking to replace cable out in rural areas and have such a box. And it's becoming more of a phenomenon today as well. But today you're delivering even higher broadband services, but also TV service that way. So it's.
So what is it? Essentially, it's a box with a SIM card, and when you connect to this box, all of a sudden you can have like several people using it as Wi-Fi.
Yes,
or something like this.
It has Wi-Fi or Ethernet.
But SIM-based Wi-Fi, if you like.
Yeah.
3G, 4G at this time?
3G.
3G.
So you have to remember at this time, 3G was pretty new. This is before.
This is even new 3G.
Yeah.
Oh my God.
3G was pretty new. There was no smartphones. There was no iPhone. You know, so
this is
Yes.
No smartphone, no iPhone times.
Yes. So you have to remember the context of when this. So fantastic meeting. The thing works. I'm happy. The customer's happy. Next meeting was just a yelling meeting where one of the three amigos sat for an hour and just yelled and told how worthless we were.
Part of negotiation.
Probably. I was young and inexperienced, and the local Ericsson team said that was a good meeting, and I was like, okay. But I guess it's something that you've learned because the meeting lasted for a long time. If it's a short meeting and somebody yells at you, you know you're probably never coming back. I mean,
but a long meeting and they yell, they kind of want to have you to stick around.
Yes, something like that. So that was interesting, and so that was my Wednesday. 2 meetings. Thursday morning, jump on a plane and get back home.
Yeah.
So
let's get back to a little bit to Australia later and all that and what that experience was all about. But let's start. Daniel Lewis, who is Daniel Lewis? What's your journey into this space?
It's a good question. Who am I? Let's start with some defining moments in my life that have taken me to where I am today. I mean, one of the big things in my life was, I'm not sure if it was Christmas or if it was a birthday or something, I got a Commodore 64 computer.
Ooh.
I mean, this is, for anybody who's likes technology or that was, wow. I can't remember if I was 9 or 10 years old. I mean, that was a defining moment. You got this thing that you connected to the TV. You could play games on it, which was, of course, super fun. Computer games, even though that were,
basic stuff, but
very basic stuff compared to today. But it was amazing. But you could also write programs on it. You could do stuff on your own on it, which was like.
Were you programming when you were a kid, or were you more of a gamer? Or both?
I was more of a gamer than a programmer, but I did a bit of both to basic understand. But I understood that computers were magic. These were really something that you could do things with and take you places. So that was a very defining moment for me. So that started my really
take interest even.
Yes. absolutely that started my tech interest. Other defining moments, I lost my dad when I was 19. He died of cancer. So, I mean, that's a very defining moment in my life. I had actually just started my degree in engineering at KTH here, Royal Institute of Technology in Stockholm. And it was tough times, and I actually dropped out because I couldn't find myself to focus on studying during that period. So what I actually ended up doing was joining Ericsson because I'd been
quite young, yeah.
Yeah, so I was
like 19, 20 even, 21 maybe.
21. Yeah. So the studying part didn't fall out very well. Joined Ericsson, and the reason why I joined Ericsson, my father had worked at Ericsson. And I'd been an intern at different parts of Ericsson during summer, so I knew some
the company a little bit, and you liked the company.
Yeah, and some people, and you call people, and say, hey, can I, continue here? Yeah. So I started that and had a very good school there. Spent actually 19 years within Ericsson doing different things. A long journey there. I
need to ask you. You told me this privately, but I think it's a cool story. Didn't you one time, and I think this is quite early in your career at Ericsson, go out to fix the PBX at Peter Wallenberg's mansion, like the CEO of, or the chairman of SEB at this point in time? This is ages back.
Yeah, so Peter Wallenberg, the Wallenbergs are the family that influential industrialists and banking here in Sweden, and they own and control a large part of Ericsson. So of course they had
good Ericsson products at home.
Well, a PBX is not something a normal person would have at home.
What is a PBX, or what was a PBX?
Exactly. So now anybody who is younger than 40 years old probably doesn't know even what a PBX is. So PBX stands for Private Branch Exchange. So it's a branch telephony system for small, medium, or large companies. So
it's a Vexel. It's a small, what do you call it in English?
Switch.
It's like a company switch, typically, right?
Yes. And he had one at home at his residence. And
so this is not a B2C consumer product. This is a B2B product.
Absolutely not. It's a B2B product, very much so. So, and how he got it and installed, don't ask. It probably came out the factory and into his house. He had these were digital phones. They weren't analog, so they had extra information and function so that, if a call came through, it would ring on all the phones in the house or whatever, if it was important, etc. You could, so several people could join the call, but in different rooms.
So we're talking 80s, 90s or something like that. I don't know.
It's
90s
late 90s. Anyway, something wrong with it. Peter Wallenberg called somebody at Ericsson, and it trickles down. So I happen to be left in the office. Some boss comes in and says, "Hey, we have a problem. Peter Wallenberg's switch doesn't work." And you go, "Can somebody go?" And I said, "Yeah, why not? Okay, I'll go. I'm here. I don't have anything to do at home right now." So, Thursday evening or whatever it was. Yeah, so I grab a cab, get out to his residence, which is outside town, pretty far out, and get let in, through the gates and everything. This is not your average residence. I mean, this is a pretty important guy, one of the most important industrial people in Sweden, and he can't phone. I mean, you have to realize, of course, he had a mobile phone, but I mean, people called fixed phones in these days, and he couldn't call out, and people couldn't call in, so that was a problem.
Had to be fixed.
So pretty big house. More phones in the house than
than the normal house.
Than the normal house. You know, I'd say even a small office maybe wouldn't have as many phones as he'd had all around the house.
It was like a full media setup, I guess.
He had the works, in the basement where the exchange was installed. You know, he had all kinds of satellite racks, and he had direct feeds out of Reuters and things like that. Of course, I mean,
well, why not? He should have.
Yeah, I mean, important business guy. Today we have the internet, so it's pretty easy. But I mean, in these days, this is what you had. So I mean, he had a setup, that's for sure.
He had a good pad.
So it was interesting. And
could you fix it?
Semi-fix it. So it kind of did some bypass, but there were several things that needed replacing because it was old, and but got it working. I mean, so he at least could phone, yeah. And then while waiting for the cab, had to sit down in his couch and had a bit of a chat with Peter Wallenberg, and he kind of asked me a few questions, what I did and so forth. And, I said, yeah, well, I do this at Ericsson, private branch exchanges. And he asked me, do you travel in that? Not so much. I hadn't started traveling at Ericsson at that point. And then, but I said, I'm half English, so I spent time in UK. And he said, yeah, I spent a lot of time, because when he was young, he didn't join the bank as the family should. So he became an industrialist. So he actually went to Northern England and dealt with machinery and shipping and stuff there. So I mean,
he has a cool background.
Yeah. So he's a proper industrialist. So he's not a accounting guy. So he's a business guy and industrialist. So it was interesting. It was one of those moments here, 21, 22 years old. You meet somebody who's super influential in
Sweden, like one of the main guys.
Yeah.
At this time.
Yeah. So that's, I mean, that was also a aha moment. You go like, wow, this is very different to what being around the office and the important guys there. This was sort of off the charts to that, But he was very laid back.
Cool. And back to Ericsson, like so what were things have you been sort of working on, or what's been your sort of field in Ericsson?
So it's
or defining moments, even, I guess.
So we'll get back to that. So I mean, in the late 90s, I started with private branch exchange. There were,
this is wireline. We talk about, we talk wireline versus wireless in Ericsson right now. Right?
Yes. So we're still pretty much wireline, but the trend at the end of the 90s going into the 2000s was there was something called voice over IP that was starting to emerge. I mean, Cisco started to emerge as a big player with enterprise data. You started to get packet data networks going. The
Cisco switches, the core switches, blah, blah, blah.
Exactly. And that was starting to eat into telephony, because you could, instead of a circuit switch telephony, you started a packet switch telephony. And Ericsson was a little late to the game. So the next defining moment, Ericsson made a acquisition in Silicon Valley, a small company, fairly small company. I think it was around $150 million at that time, called TouchWave. And I joined sort of a team here in Sweden that was going to work with this new this voice over IP product and bring it into Ericsson. And so I started going to Silicon Valley, and that was a defining moment for me in my career at Ericsson also. To
get the vibe early. You got the vibe early.
Yeah, it was so different. I remember first time coming in, they were based in, I think it was Mountain View. They were originally based in, and come in to this office, and it's only concrete floors. It's cables all over the floor. There's just these cubicle walls set up here and there sporadically, and it's like, I was like, is this an office? It was nothing like in Sweden's everything's organized. Everybody had a room and all these kinds of things, and it was like, where am I? What is this?
So what is it like more hardcore factory garage tech? Just tech focus,
yes.
tech.
There were just people were there, you know, they were sitting coding. That's what they did. And it's like, it was
different vibe.
It was very different. But the one thing that they did have, this is a Silicon Valley thing that I discovered also later, that any company really you go to. I don't know if that could have changed. They have a kitchen area. And it's loaded with soda and snacks and stuff just to keep people happy.
And keep working.
Keep working. You know, there's always something to eat, and you know, it's you know, in Sweden we have the coffee machine, which is like the holy grail. This seems to be like the Silicon Valley,
the snack
you know,
area.
the snacks with the sodas and so forth. So, but the experience of being there, it was like, it wasn't important, you know, what it looked like. It wasn't important. It was, you know, it was sitting there coding
But it was tech code is the holy grail.
Yes. It was, you know, people sat there and worked, and we need to get this working. And it was an interesting and learning experience.
And when you did this project, is Ericsson still a wireline company, or has it started to emerge as a wireless? When is the defining moment for Ericsson here to become a wireless company?
I think that had already happened, but we belong to another part of Ericsson that was still the wireline. So Ericsson hadn't given up on that yet. So we were still in the wireline space. But after this period with this product and I moved into wireless, that was sort of my next step within Ericsson, because the wireline side was going downhill more or less. I mean,
could you see as an industry, as a company, where this was where the trajectory was for?
Yeah, it was starting to go downhill. I mean, people adopting cellular at a very. I mean, it started to really boom among consumers, that people started buying phones, because when I started Ericsson, it, you know, mid 90s. I don't know how many had their own mobile phone. That wasn't that common, but it gradually started growing, and you know, everybody started having a phone, and you know, I saw that this is the future. I mean, it's going to be wireless. That is definitely the future. Mm. So that's how I kind of moved into wireless, and then started looking at. So that's how my first product, moving into product management, was looking at, well, how do we replace wireless or wires with something wireless that gives you that same functionality? And initially was, you know,
voice over IP.
No, not really. But you know, you cut the cable, you put a box in instead that uses the wireless network, but you stick your phone and your broadband connection into that, rather than you have somebody that's pulled out cable to your house or whatever. So that was my next journey in there, and ever since it has been sort of on the wireless path with the different technology. So it started with 3G, and now we're at 5G.
And then some point here, I think you went into Ericsson Enterprise, the products you work with that belong to one function within Ericsson, which is more enterprise product, or
that was the PBX side.
That's the PBX side.
That's where I started.
Okay. So and when is the transition here to Sierra? Because what year is that?
What year is it? Well, so. I usually think it wasn't long ago. I haven't been at Sierra that long, but it's actually 7 years now. So it's so in 2013 I joined Sierra Wireless, and the reason for that. So after some of my fixed wireless endeavors, I started sort of going more low level into that, and we were doing something called wireless modules. So this is the precursor, I would say, to the IoT and M2M world that we have today. It was building, in that case, it was broadband modules to integrate into laptops and other devices to have a cellular connection in them. So
this is like, if we go back a couple of years, some people remember it, you were able to stick a SIM card into your PC, stuff like this.
Absolutely.
And your technology was essentially the module that was in your Toshiba or in your Dell computer.
Yes. So
you sold to Dell and to Toshibas and the likes.
Yes.
As an example, yeah.
As an example. So it's an alternative. It's not a mobile phone. It's only the data part to enable a broadband connection in any device. So Ericsson did that for a while. You have to remember, this also started pre-iPhone.
Yeah, this is pre-iPhone.
When this all started up. But
pre-iPad.
Pre-iPad. So, and at the time, Intel was pushing something. So we talked a lot to Intel. Intel was pushing something they called a MID, mobile internet device. And what do you know, in, I think, 2010, 2011, what came out? Apple brought out the iPad, which was literally MID, mobile internet device, but done
their way.
I mean, but it had cellular connectivity. So it was sort of, all the ideas have existed prior to that, but I think Apple sort of nailed it with an iPad with what we were doing. So that was one of the sort of type of devices. And then we started looking at how do we go broader with this? How do we go outside the space of computing and that? And
SIM cards everywhere. Or now, so this is sort of ramping up to Ericsson's call connecting 50 billion connected devices or something like that. So this is a couple of years earlier, but you were in the position. I think we talked about this even back then, how this was emerging in this direction.
Yeah. So Ericsson coined, they had a vision that by 2020 there would be 50 billion connected devices.
How did we go? Do you know the stats?
I think they talk about 30 billion in there, but then you can discuss whether they are cellular or other technology. Yeah. But there's a lot of connected devices, but there's still a lot that is not connected. So I mean, we started looking at sort of the broader scope, but then Ericsson decided, for different reasons, that Ericsson is a network company, focus on the network rather than the device side. And that's when I decided, well,
you like that style.
I like the devices. I like the stuff that goes into people's hands or into somewhere where you can touch. The network is, it's more abstract,
more back end.
It's more abstract, and if you work with a network, you don't really work with the whole network. You work with a tiny piece of it. Whereas end devices, it's something that you can touch and hold, and more relate to.
So. And then Sierra Wireless, which, I mean, like maybe not everyone in Sweden has such. I mean, like Ericsson is a household name in Sweden. In Sierra Wireless, it's a Canadian company, right? So yeah. So let's do the company and the story at Sierra.
Yeah. So okay, Sierra Wireless. So. I knew Sierra because if you're in the industry, you know who's in the industries. But
so they were your competitors, in some ways.
Kind of, yeah. So they're definitely a competitor. I mean,
to Ericsson at that point in time.
Yeah. So Sierra Wireless is a pretty old company. If you look at the industry they're in, they're 27 years old, and
with wireless,
and focused on mobile data and enabling mobile data into devices. They started also with computers and gateways and catered particularly for type of rugged type of installations and that. So small company that's grown and grown and grown. So when I joined Sierra, we were around 650 people. So fairly known in the industry and fairly, pretty global presence in all the continents. And while I've been there, Sierra's been on a journey as well, from going from a hardware company moving into a more of a service company and building a more complete stack in the IoT space.
So let's talk about that. So let's talk about Sierra. But what does that mean to be? What does that concretely mean? Going from hardware to what does that mean for Sierra?
Yeah. So for Sierra, that has meant. So I mean, if you look at it, so Sierra had a broader view of the market than Ericsson. They'd started looking earlier at not only enabling PCs and broadband types of devices. So they had other types of devices that didn't need that amount of data. So they had made acquisitions and start forming their company. So there you talk about very low bandwidth applications, but still needed to be connected, like, I don't know, for temperature measurements or whatever. You have
so the spectrum was wireless connectivity.
Yes.
End to end. To some degree, or not end to end?
Not end to end, but selling hardware into those spaces.
But I don't mean end to end, but there are many types of connectivity use cases, and
yes.
the full spectrum of connectivity use cases, where sort of 5G might be on the higher spectrum of what you really need into connectivity, and then you can go down to.
Yeah. Correct. So Sierra had a much broader portfolio to address a larger space of the market.
The connectivity.
Yes. Of enabling the connectivity. Yes. Whereas Ericsson only focused on a much smaller piece of it. And how that evolved and the journey that Sierra's been on is well, if you sell hardware, you just kind of sell it once. Somebody does an integration product and then they buy hardware, and that happens typically mostly on a project basis. So like you are there to compete to get your module into whatever they're building, and yes. Then you're going to build, and then you're going to sell that, you're going to produce and supply that module as long as that module and that life cycle of that product lives. Is that fair? Well, in general, yes, but I mean, we don't make custom modules. It's generic modules, so there's several there'll be many customers, but
but you're trying to get them to buy this particular module in our assortment,
yes,
in order to solve the connectivity for this piece of
hardware
or something like this.
Yeah, correct. And well, once you've done the sale, I mean, then that's kind of finished with your relationship. We're
a supply chain relationship going on.
Yeah, maybe, or they just buy in one shot, and then maybe in 5 years they'll come back. We're going to make a new product, an upgraded one, and you don't have so much of of a relationship there in between. So it goes kind of quiet, or you just have a supply relationship, as you say. Mm-hmm. So what Sierra has done is if you look at connectivity, what you need, you need the hardware to enable that, but then, the magic is the SIM card, the service, right? But if you look at traditional carriers around the world, they cater. Who do they cater for? They cater for consumers. They cater for mobile phones. That's what their business is centered around, right? So, but if you're connecting a machine, you have a totally different point of view. What is important? I mean, typically you don't need speech. That's unimportant. But what you do want is kind of reliability. What happens if the network goes down? I still need my machine to be able to communicate. So how do I do that? So it's more important. I want some sort of failover between networks and that. I mean, if you have a SIM from your provider here is Telia or Telenor, if that goes dead, if their network goes down, your phone is dead. But if you have a piece of machine, that might not be an option, right? You want it to fail over to whoever there's a connection to. So Sierra looked at it, said there's an opportunity here that in this space, there's a need for a different type of connectivity, a connectivity for things,
and even a different type of carrier or operator type contract.
Yes, because the business model is different. I mean, a traditional carrier, what you send, you've got this bundle. It's so.
Yeah.
Sorry. Okay. So the contract says you buy a bundle and that's it. But that's not maybe how the machine you want to do the business. You might want to buy the data for the whole life cycle of it up front. You might there are a number of different ways when you connect things how you would like it to be, rather than
what we're used to it
as a consumer with a phone.
Thanks.
So Sierra did some acquisitions, what we call MVNOs, which are mobile virtual operators. So what that means is that they don't have their own radio network, but they have their own core network and can issue SIMs and so forth. So they have contracts and deals in place with the traditional carriers to use their front end, the radio network, but in the back end, they take care of the data in their own network. So Sierra's done a number of those acquisitions and become a global mobile virtual network operator for IoT.
All right. So now we're moving into what is product even? So, so clearly we're going to get back to IoT and all that, but I think, as a theme in between here is a little bit like there is a shift now of the physical product and even the physical component as a product that you've been experiencing to basically now, we need to be an operator, we want recurring services and stuff like that. So, but before we go let's start with the basics. What is a good product, or how do we look at good products? What's your experiences thinking about product, and how has that evolved?
Yeah, so this is again, being passionate about products and that it's fit for purpose, because I think we tend to build things that are good at many things, but not very good at something specific. So you end up, always have to compromise. So you can't be everything for everybody with a product. And I've always, something that I think the school at Ericsson and with product management and that I learned a lot of good lessons there. And what's important to have is the product view. What should we be doing? What should we say yes to? What should we say no to? Managing cost. Because you get carried away, especially when you're young and it's not your money. And this is also tying back to the Silicon Valley view that, you have to have an idea where you're going, and you have to say no to other things in order to be successful and to get the product right and get it out.
And I think this understanding of what is your core value proposition, or what is it that you're trying to achieve. I think moving into the data and AI space, sometimes it can feel, this is my personal view, that the hype or the tech almost interferes with, what are we trying to build here? We need to have big data, or we need to have IoT, we need to have 5G. Actually, what's the use case and what's the product's going to do? And now we're using a broader term, like it could be a service, of course, like this, but having this product thinking in terms of what's the purpose of what the use case that you're trying to solve. I resonate a lot with that.
Yes, and I think too many people just go, it's like the internet was new. I have to be on the internet, but why? What is it that you want to do? I don't know, but I have to be there. It's like, I need 5G. Why do you need 5G? I don't know. It's new, and I need to be future-proof. And it's like, but you have to boil down to use cases. I think is a very good way of looking at products and services. It's what are we trying to achieve here? And try to set boundaries of what we're doing, and not, it's like, hey, let's build a module that does everything. Let's make it do, all radio technologies, but then it won't do any of them really well. And, who are you addressing? So I mean, this.
But I think this is a lesson really, truly, strongly learned if you work in a company like Ericsson, who is maybe some of the best in the world around product lifecycle management. They are really good at this.
Yes.
And they have a really strong process for trying to understand even how new releases should have different features, like a new radio base station we talked about in 4G, I remember, and used to prioritize where to take that, the next release. And I think the software companies as well, they figured this out. But I think this fundamental product thinking truly applies to a lot of stuff we are trying to do now in society. If I'm in the public sector trying to fix some administrative processes, or if I'm in at Scania, or I'm trying to fix some workflows or something like that, to have that very concrete idea, what are you trying to fix? I don't know, and not get, and really nail that down. To me, that is a lot to be learned from the product companies, that you really need to be good at this, even when we do data and AI and these kind of stuff.
Yeah, I think you're absolutely right, Henrik, because you so easily get lost, and I think public sector is especially lost because, again, it's somebody else's money you spend, so you can go and do whatever, and you go and do things broadly, and things never come about. And I think Ericsson had a large project. I don't know if it was late 80s or beginning of 90s or whatever, where they tried we're going to do the final solution of a switch, and they spent years and millions, and it never amounted to anything. And I think after that, I think that's how Ericsson learned, okay, we need to focus on products and what they do, and have a proper education program around people who are responsible for our products, and learn to prioritize and focus on the product and how we build products, so that it's a venture cap model where you work out the numbers, and what are you going to build, and what. Yeah, well,
let's talk about a common story we have at Ericsson, where I was a consultant, and you actually been to a student to one of my classes.
Yes,
which is funny, right?
Yeah, that's
and it's quite interesting. I couldn't teach you anything in one way, but what really impressed me with Ericsson, and I think this tells you something about how to go about this, is that. Well, you tell the story, but it was this fundamental understanding: how do we put an industrialized understanding for product lifecycle management in place at Ericsson, and how do we get all the different parts of the whole big machinery of Ericsson to understand their part and their story and their contribution as a global team, as supply, pricing, R&D, how they all fit into this puzzle to create great products. So tell that story. I think that's a lot to learn around. If you want to industrialize anything, you kind of need to do something like that to set the standards of a company.
Yeah, and I think the governance around it also, like with very clear milestones and steering groups that is venture cap based, that you look at the numbers and say, it's a very good model, and I think Ericsson has mastered that very well. I mean,
I've been, me as a consultant working with you has taught me that, and I've been using that ever since. And now we talk about lean startup. Eric Rice is the grandfather of the lean startup movement and all that. But Ericsson had that perfected, way before, because I have the proof, because I made the curricula around this. And it wasn't me who made it, but the whole idea, what we did was that we took Ericsson's best of the best. Like I remember it vividly. I had a sponsor in Erik Bertels. If you remember him, he was heading up the product lifecycle management process.
Yes.
So his job was basically how do we get Ericsson to work as a machinery in a lean startup venture capital way. So what they did brilliantly was to understand the fundamental phases of venture capitalist. What do you do in the idea phase? What do you do in stage one capital? And then basically understood how do we weed out good and bad things. Do we basically decide, clarify what we need to do, and then build it. And the whole idea fits really well with the new concept of lean startup. And we say, we need to fail fast. Because the whole idea with the Ericsson model that we worked on, and this is way before this is in any, this was not in any papers, this was not in any books, but with the venture capitalist view on this, it meant we focused the whole of Ericsson to weed out with the least amount of effort the bad ideas. So basically, you don't go into really heavy stuff until you know what you're doing. Yeah, super brilliant.
Yeah, correct. But I think, Ericsson being a big company, it's impressive that they do that, but it's hard because it's such a big organization. There's so many parts of a huge company that needs to fit into that model. The one thing I can say in hindsight that
could have been better,
could have been better is that because all my projects, so I've been shut down 3 times at Ericsson with things I've done. So starting with the Silicon Valley experience and that acquisition, eventually that went away, that got shut down, and then the modules also got shut down. So and I've worked on
a strategic direction goes left.
Yeah. Or you could argue that everything starts small. Things don't happen overnight. All companies started off small. No company started with a dominant market position or owning the market or it started in small steps. And I think that one of the things that I have a hard time with is that you need some perseverance and a longer term thinking that, it's not going to take off, the first, second, third, or fourth quarter. We're talking years here instead, that you have to have a bit of a longer horizon until things happen. That doesn't necessarily say that you're going to throw lots of money and spend things forever, which, with a venture capital model you won't. But, we have to get away from more of this short-sightedness. And I think that is extra challenging within a big company, because if something doesn't fly there, we're off to the next thing. We'll try something else. And that makes it hard starting new things within a company. I think it's easier. That's why startups can come along and be successful and grow into huge companies, because it's easier there.
But here, let's finish the product and what is a good product and this first, because then we can after that move into the theme around KPIs, budgeting, quarterly time steering. How does that really work in terms of innovation and product? But to summarize, a couple of things here, which is sort of takeaways also for the data and AI space. An industrialized approach. We are not talking now that, it's more about the mindset and how we are putting frameworks in place for the whole company organization to know their part. And I think that way of that Ericsson did is completely applicable to data and AI. When you have a data engineer, you have a data scientist, you have a service designer, and these guys need to work in unison in order to go from idea to production, right?
Yeah.
So I think the main takeaway of some of the, what is making Ericsson succeed is this this understanding for how to industrialize things. And basically, if we now concretely talk to the people who hasn't worked with Ericsson, what does that really mean? Well, it means that you don't go in generic trainings. It means Ericsson takes the best of the best concepts and then figures out what's the Ericsson way we're doing this. And then basically when we talk about the process or product lifecycle management or supply or pricing, we are taking it to world-class the way Ericsson does it. And I'm super impressed with that whole stamina to then say okay, all product owners and product managers in Ericsson, they kind of need to have, they are free to do whatever they want, but they kind of need to know how the machinery works.
Yes.
And they get taught how the machinery works. And who does that? No one does this.
No, it's multidisciplinary, as you say. So everybody has to fit into this model, and it has a set of rules that you have to go. But the idea could be anything.
So the whole to unleash innovation, that fastly scales to product innovation and scales globally is like, we have this framework, we have this machinery, it works like this. And I teach you now the machinery, so when you get your job and you can go crazy, but know how the machinery works and you will succeed. So I think Ericsson mastered this way of product thinking in some ways. And that's, I think this is part of their success.
Yeah, I mean, they keep churning out new products and services that are top notch in their industry. So for sure, but I think when they get out of their comfort zone, doing something that they maybe that becomes harder.
I mean, like, so the problem. Okay, so what's the downside of the way of working? So the way of working, the frameworks, they are really geared to a certain type of core positioning.
Yes.
Right? What Ericsson has always been good at, working towards the operators.
Yes.
So all of a sudden, when you move innovation full on, away from your sort of core domain expertise, not as sharp, maybe.
No,
or it's tricky to make it fit.
Yeah, I think it's more of a fit, and that people think that they're outside their comfort zone, and also based on strategic direction, right or wrong. I mean, somebody has to run the company and decide where we're going, and if it doesn't. But that's also part of just like a product. We have to know what we say yes to and what we say no to. And no company has unlimited resources. So if it doesn't fit where we're going, then maybe it's more right to say no. And the same is whatever service or the thing that you are conjuring up, you should, fit for purpose is something that you should do. Does it solve the problem that you're looking for? I mean, it does. You don't need 10. If you only need one lever, just make one lever, not 10.
So, and this also becomes this whole idea: lead with the business problem, the use case, and don't lead with tech. Because when you lead with tech, someone who's going to sell you tech, or when you're going to install the tech guys will talk about, we could have this scenario, and we could have this scenario, and we could have this scenario, and you end up building this huge gizmo.
Yes.
When you really only needed one lever, and I think and the cost, everything, and this time. So stay the course, keep focused, understand what you're trying to build. I guess.
Yes.
That sums up that product.
Yeah. I mean, AI is supposed to help you, right? You want an answer to a specific problem. You don't want to know 10 other things, so don't lose sight of what you're trying to solve. Then you're usually, I guess you're more than 80% right then.
Yeah, and the point is then, for smaller amount of money and effort, you get something that works, that does the purpose, and then maybe you can grow from that. You can grow the features from that.
Yes.
Okay, but let's finish the product theme. But I want to do this now, if it's okay. We need to talk about the theme around innovation versus the quarterly budgeting setups and all that kind of stuff. But before we move there, I think there's some more. Going into Sierra, I think before we talk about these types of technologies and services that also comes with IoT, let's really start breaking down, the introduction to IoT. How would we define it? What is the different things? So, because I think there is a lot of problems when we are using new words and we hype them up, and IoT becomes the new hyped word. But I mean, let's break this down and get a little bit nerdy a little bit. What is to you IoT, and what is the fundamental components of it and stuff like this?
Oh, yeah. So, I mean, IoT, it used to be called, before that, it was called machine to machine, so M to M. It was machines talking to machines. So it's Internet of Things is just, I see it as machine to machine was, in its infancy. We're talking about maybe only a few things that we're talking to a few things. But when you talk about IoT, you're really talking about the, connect everything. Everything should be talking Everything, exactly. So, and IoT is not one thing. It's a bunch of technologies, and there's many ways to do it. So I mean that's why you can't say it is this or it's that. And again, bringing back to the fit for purpose. I mean there's proprietary technologies that you can put up your own networks to do. There's LoRa, Sigfox. You can use traditional things like Wi-Fi, Bluetooth. There are others, short range technologies like Zigbee. There's a whole bunch of things that fall under the IoT umbrella. And
but let's break it down, because I don't think people talk enough about the fundamental journey of something going from here to here. Like what are we talking about here? Let's be super concrete. So I'm in this piece here, machine to machine or whatever we want to connect. So concrete down on bits and bytes level. What do you need to do to get the sensor to work? Let's start here. What's the chip? What's the sense? How does wireless really work?
Yeah, well, how it works. Typically, you'll have some gizmo or something, that measures something. I mean, that's a typical,
All right, let's take a concrete example. You choose a use case or scenario, right?
I mean, you measure temperature.
All right, let's measure temperature.
Or humidity or whatever.
We have a temperature station in Arvidsjaur, and we don't want to go out to the station and read it anymore.
Yep.
So what's the fundamental technical journey we're talking about?
Yeah, so to get some efficiency, I mean, if you have something remote, and if it's to be read manually, so how many times a day can somebody read that manual? Well, if it's somebody local, maybe he can go there a bunch of times during the day, but it depends. But maybe you want to have measurements of the temperature every hour. Okay, so then you have to send somebody there every hour, even during the night. Is that feasible? And the more remote it gets even, less feasible, and also more costly, of course, because you have to employ somebody that gets out there. So we'll look at a remote weather station. So ideally, you could have short range sort of technologies that you would hook up to the sensor. And
what do we mean short range technologies?
Well, you could have a local Wi-Fi network, but seeing if you're out remote, that's probably not plausible. More likely you would have a cellular network, because cellular coverage, it's pretty good, but maybe not all encompassing. Worst case, if it's too remote, maybe you're talking satellite, but you'd need some sort of component that you stick to your sensor that can communicate with the other world.
So it starts with the sensor at the actual thing doing the reading of something.
Yes.
And this could be reading of temperature, it could be reading of anything.
Yeah. Anything.
And basically what the data point that you want to collect, that will tell you what type of sensor you need.
Yes.
And then from here, okay, the next step is to send it somewhere.
Yes, and you need to have a network which you send it over, and whether you can build your own little network, or you could use something that exists, or satellite, whatever. And seeing that I come from when I talk about wireless, I talk about cellular wireless, the standards that.
And what is the definition of cellular?
In my world, the cellular standards, it's the broad standards that we know as 2G, 3G, 4G, and 5G. It's the 3GPP partnership project that defines the cellular standards that move forward. There are other.
So this is a protocol that's been standardized within the actual telco, I guess, industry.
Yeah, and it's become, I mean, it wasn't all encompassing from beginning.
I remember the CDMAs, and when this was a mess, right?
Yeah. So if you go back, there were, and the cellular standards have, they've gone through. There's a first generation, and the G stands for generation, by the way. So they were analog, and then the second generation that's known as 2G was digital in terms of transmission. But there were different standards, that were diverse. But the standards body has
improved.
Well, people have come together and understood that in order for things to scale, to get the benefit of a massive scale, which mobile phones are, everybody has to be on the same standard. Because if I, even though I'm maybe 50 million here, compared to 7 billion, that's not a whole lot. If you're connecting everything, you want everybody to be more or less on the same standard.
When was the real shift? I mean, like in 3G, we had several versions, right?
Yes.
We had, CDMA, NTMMO in Japan.
Yes.
And we had LTE not even LTE yet.
No. So LTE was more or less, then everybody came on the whole.
LTE is when everybody came on board.
On the same train. So yeah. Before there were different trains.
So LTE is really 4G train.
Yes. So that was the first
true all-encompassing cellular protocol.
Yes. So everybody on the same train and in the whole world.
And if you can now compare LTE, that type, what are we talking about bandwidth here? And how can, now we're talking 5G soon. Let's talk about that later. But 4G is here. But of course, there are other protocols which are very much more low bandwidth, more like cheaper, or, there are different protocols here fit for, you always say to me, horses for courses or fit for purpose.
Yes. And you have to recognize. So I mean, the mobile phone industry has been on a track, higher bandwidth. What is it that people in a phone consume? You have to understand that, of course, that is also fit for purpose. People watch videos, and
now we stream massive.
And the networks have been optimized, and the industry optimized for that. So there's been a bunch of protocols within the cellular standards that have shown up that are for low bandwidth applications. So there was kind of a split where they came out. So,
and which one are the major protocols in low bandwidth?
There are two. There's one called NB-IoT, which stands for narrowband IoT, which is very, very narrow. We're talking kilobits.
Then kilobits is like small packages.
Yeah, so that's thousands of bits of kilobits. So think of it, comparable to the speeds of 2G phone. I mean,
old school. But if it's needed, if
you just if you're doing temperature measurements, you
don't need more.
You don't need a whole lot. And there are certain traits with NB-IoT and that we can go into that in just a bit. And then you have another technology called LT-CAT-M1. And that one has a bit more bandwidth. It's hundreds of kilobits, you would say 300-400 kilobits maybe. Whereas NB-IoT is maybe 50 to 100.
So what we're talking about here is to really understand your use case in terms of what's the size of the package that you're trying to send and to what frequency, stuff like this.
Yeah. So it's a fit for purpose, and another fit for purpose is the thing going to move about? Is your asset going to move, or is it
you have an asset in a mine, like a caterpillar in a mine, or do you have something stationary?
Yeah, exactly. Okay. Or is it a logistic truck? Is it a truck that moves around the whole country? Then it needs mobility, because here's also a difference between NB-IoT and LT-CAT-M, where CAT-M supports mobility, where NB-IoT doesn't. But they have different use cases. So this is what you need to do. You can't just say, "Oh, this is better than that and that." But it depends what you're doing, what the purpose you're doing.
So back to the product topic. So what is your IoT use case really all about? Are you Maersk driving shipping containers? Are you Scania working with trucks? Are you Tesla?
Mm-hmm. Yeah, exactly. What is it that you want to do? I mean, are you in a manufacturing plant, or do you want to track where all your tools are? They probably don't move a lot. They're more or less a fixed asset. So, but want to know where they are for different reasons. So, I mean, this is where so those are two of those cellular technologies that have emerged, in the past 5 years that are specifically, I would say, for most of the for most of the IoT space, and they're known as LPWA, so low power wide area technologies.
And if you define, what am I looking at when I'm looking at one of those gizmos? What is it that I'm actually looking at? Is it like a card, or how does it look like?
These types of things are pretty small. Think of them, as maximum like 20 by 20 millimeters, and size. They're small. Looks like a system on a chip. They're totally encased.
You put it on the motherboard somewhere.
Yeah, you attach it to a PCB where you have your sensors and where you have a microcontroller or a CPU and some memory, and you have an operating system, and you write some code so that the sensor does the measurement. You take that, and then you take that and package it, and use that connectivity of whatever technology you have to send that up into the network. And
where does it go? Okay, so now we have sort of taken, I'm trying to figure it out. So we've taken the stuff, the breeding, we have the little gizmo that is now cellular maybe, and we have sent it somewhere, so we're sending, what are we sending? Data, and we are now thinking about different, from small kilobits to larger packages.
Yes.
And we are sending it on the network. So typically, are we now connecting then to what you highlighted Sierra has there? If you take the Sierra example, it's a machine to machine.
Yeah. So in our example, you would still, if that weather station that's out in the middle of nowhere, so it would be going over a carrier network to the radio base station.
So the radio base station part is the carrier part.
Yeah, it's still the carrier part. We don't have that. But then we would have an interconnect in the core network where that data would be routed to our network, and we would take care of that. So what it also means, so it means that in the gizmo, in the weather station, we would have our SIM card. And what that also would enable is that, say the weather station is located at that point, you can see two carriers. There's carrier A and carrier B has coverage there. I mean, that's pretty important. So our SIM would attach to either or of those networks, because we have a deal with carrier A and carrier B. So because the weather, the person that's taking the weather data wants to be sure that regardless what's happened, I always want my data, right? But if he had a SIM card from carrier A and his network goes down, he wouldn't be on carrier B when that happened. He'd have to wait until carrier A has repaired his network.
Yeah, well, so the business case when we go B2B is completely different, right? Because it's like one of those things that cannot break down. It cannot lose. So the carrier is actually now replaceable, Yes. So let's do them, but let's have 3 or 4 different options.
Yes.
But the data still needs to go and needs to go somewhere.
Yeah. So what our SIM does is, based on customer preferences, it will select either carrier A or B, depending, be it quality of service metrics. So the carrier with the strongest signal is our first preference, then we'd use that. If it's the cheapest carrier that you have a signal with, then it would be that, for instance. So there are different, metrics on that. But it would then be routed through our network, and then it would be hooked up until the data would be delivered then to a cloud of the person that's collecting the data at the weather station of his preference. So if it's IBM, if it's AWS, or... So
basically now we have sort of taken the path from the sensor
through the network
where we have, failover on carrier level, and then basically routed in from your part into whatever is the central cloud or whatever they need.
Yes. So the repository where they collect
at the customer's site, or now we're at the customer.
Yeah. Now the customer has that, and what we do is also we do that in a secure manner, because at the end of the day, weather data is maybe not very sensitive, but in a lot of cases there might be sensitive data, and then you have to make sure that from A to B that you're covered in terms of security, because that you don't want somebody listening to that data and stealing that data from you somewhere in the middle, because that's data is our new currency. So I mean, it is valuable.
So basically, the executive summary of the introduction to IoT and wireless is like, number one, we have different types of horses for courses, fit for purpose bandwidth, depending on what type of case you have. And it has also to do not only with the size, but also if it moves around and stuff like that. And then basically we have the understanding of we have something, we need to have a reader sensor, and then we need to send it. And then the way we send it, if we want to do it B2B machine to machine, a good thinking is to, how do I have failovers on several carriers, but still getting my data all the time?
Yes.
That's the fundamental scenario that you kind of need to think about when you do mission critical IoT. Is that a fair sort of?
Yeah, that's a high level set. But then you can make things even more complicated.
Of course you can.
So I mean, say if I'm a regional or I'm a global player in weather stations, right?
Yeah.
So I need to send these in say 57 countries. I'm going to put.
Yeah.
Okay. So if I don't have, in those 57 countries, there's 57 different carriers multiplied by how many there are.
So it's not only failover of 2, it's 2 times 57.
Well, I wasn't thinking about the failover, but how many negotiations do you have to get into in order to deploy that as a customer? If you now have an IoT partner like Sierra, we're not the only ones, but I mean, you have to think in those terms because this is different. So
you flip the whole game is shifting when you go global and B2B.
Yes.
Okay.
I mean, as a consumer, a consumer lives in one country, but if you build a product or a service, you don't know where it goes, and if it needs connectivity.
And if you have if you have long haulage, or you travel, or you have a Maersk, you travel across several carriers across the globe as the container moves or as the truck moves.
Yes. And you have to have deals with everybody. I mean, you can go to carrier A and they'll have roaming deals. Say, even if you're in 57 countries.
They can have roaming deals.
They have roaming deals because that's basically what it is. I mean, Sierra has, 800 roaming deals. So, I mean, that's why, we can get pretty much on any network. So, I mean, that's the value to customers. So if you're building your product, your gizmo, you have a sensor, you want to get the data out, you want some sort of security in terms of it has to work all the time so that you have a failover. You want it to be delivered securely so it's there. But you also have the case where you have deployments in many countries. You don't want to go and negotiate with a number of parties. You want to go to one. Okay, I can get my hardware, I can get my connectivity there, and it will deliver my data, and I only have to speak to one person.
But I think a little bit like what I'm hearing is like when you're going into the real IoT space, like when you want to have data points on sensors like this, you're opening up a new can of worms of. That's what I'm hearing. Like, how will you're finally done. You got your data center sorted. You think you're pretty cool, right? You've done it, and you got your WAN connections and your LAN connections for your offices. I know my shit. I know my connections, and here we go. Sensors moving around in the world potentially, right? And then it opens up a completely new package of things to consider in order to do this smartly and cost effectively.
Yes. I mean, the world is big, and this is what we forget. Where data-centric customer or companies like Facebook, Googles of the world, they exist everywhere, and you just when you log on, it's just there. But when you come into practicality in the IoT space, and when you use cellular networks, it's like, oh boy, if I'm going to be in all these places and, it's not one person I have to deal with. It's masses.
And isn't this another way? Like we look up to these tech giants, and some of them are very consumer oriented, and the consumer dimensions of an analytical model, or this consumer complexity of dealing with one phone or their sort of local smartphones, is nothing compared to when we go into the B2B industrialized like the real revolution is machine to machine, and now it really explodes in all the data we need to capture. But there's a huge different piece of, how does the analytical, everything is way more complex as systems. Yes. That's what I'm hearing.
Yeah, it's more complex because businesses are located in more locations, and then of course you have the security aspect. I mean, in the consumer, it's really privacy concerns, really. So it's more up to you as an individual. But I mean, the data that a company has, that's its lifeblood. I mean, in now and in the future, I mean, data is the currency. So I mean, you don't want it in somebody else's hands. So it has to be secure. You have to protect that asset. So I mean, it becomes very much more complicated. And then who do you want to rely on, and how many parties do you have to engage with in order to make
make the chain work, right?
Yeah. So it is a complex world, and for you that deal, I mean, higher up in the stack, when you have the data and model it and do the smarts on it with AI and machine learning models or whatever. But I mean, the gathering the data is what I refer to as plumbing, or in this case, smart plumbing. It's something that has to be there. It has to work well. It's a prerequisite.
But let's come back to that. But okay. But here we have now the introduction to wireless and IoT 101, and let's now go into 201 and talk about 5G. So let's now, okay, so all of what we have learned now in the first 15 minutes, what is 5G and what's the difference? So what does it add to what we have now said?
Yeah, so 5G is a lot of things, but what I would describe it for is it's more of an umbrella, right? So it encompasses these low bandwidth technologies and the ultra high.
They're both in there.
They're both in the same standard, and they're also 5G is thought a little bit more around use cases, so that you can see it encompasses things like has a whole own section for like vehicle V2X, which is vehicle to anything communication.
So you have your 5G as your umbrella sound that we know, but if you're knowledgeable. You can peel the onion and go down to 5G automotive.
Yes. So you have 5G automotive, you have 5G private networks. So you have private networks so that enterprises can build their own small private cellular networks. You have the mobile broadband, which is the consumer with the mobile phones and so forth. That still exists. And then you have the low speed technologies. I talked about NB-IoT and LT-CAT-M that will evolve with certain enhancements. They're pretty done.
But I don't get it. So you have 5G on the top here.
Yeah.
What does it mean when I go into 5G automotive? What has happened? Have they figured out even more detailed standards, or what is that all about?
Yeah, so there are a set of standards to cater for those specific use cases. So that's what it's really done. So those things aren't needed for a mobile phone, for instance, or they're not needed for if you're connecting your sensor or
so horses for courses in 5G.
Yes. So that's why you can't. That's why the question you should ask is, okay, I want 5G. The question is still, what do you want to do?
Exactly. Okay.
So and then you can start looking at, okay, so do I need high speed? Do I need ultra high reliability? Do I need something automotive that talks in the car and between cars and to smart cities to regulate traffic flow? Or do I need, from the use cases that are defined within the 5G standards?
But another topic, I think you told me, I think it's from you, I got this knowledge anyway. I mean, like you always say something that there's a major difference between 4G and 5G. It's also in about the upstream and downstream and stuff like this. So there are some fundamental things that happen when we went to 5G. What are those?
Yeah. So when it comes to, I mean, data and the different Gs, I mean, the speeds have generally gone up, but if you think about the phone that you have today and the service have today, you know, it's asymmetric because it's optimized for consuming. It's for
streaming coming to you to
yes.
watch something as an example. Yeah.
Yeah. So that's a typical B2C scenario. I mean, and anybody who wants to download something from somewhere, right? Mm-hmm. But if you start moving into using cellular technology in a business-to-business environment, you're looking at things that might want to send a lot of data the other direction, and the networks haven't really been catering to that. So that is a bottleneck. With 5G, that is going away. So it's becoming more asymmetric, and you're increasing the speed in the uplink. So
it's not only that it's more speed, it's also the symmetry
yes.
of load upstream and downstream, yeah?
Yeah. And it's also the amount of, because...
And how big is the difference in speed? I don't know. What's the difference in speed we're talking about? Yeah. Or capacity? I don't know how you want, what's the KPIs here?
Yeah. So you're basically talking that in terms of when you talk about the uplink, you're talking 5x and more, depending on
five times and more.
Yes. So, but it depends. Again, it depends on the spectrum used, because 5G again is in order to achieve speeds, you need spectrum. So,
and what is spectrum?
Spectrum is
bandwidth.
How should we explain this? But I mean, a radio is a bunch of waves in the air, right? And you can only fill it so much before it gets congested, right? And in order to carry more data, you have to use new frequency bands. So if you take a standard radio, I mean an FM radio, it transmits in megahertz, right? Mm-hmm. Well, if all your radio channels are full, you have to move somewhere else, okay. And then you move into.
You move to a different spectrum. So I'm in the 800 to 900.
Yeah.
But is that what you mean?
Now you move into the gigahertz,
okay? Because
we're and the higher up you move in the spectrum, there's more spectrum available. But at the same time, the higher up in the spectrum you go, you get more capacity, but the distance it travels shortens. So
so higher up in the spectrum means it's good signal, but not so far.
No. Well, the signal quality, it doesn't depend on that, but it depends how far it can go. So you have a lot of capacity, but it doesn't go very far.
And what is not very far? Are we hundreds of kilometers, or?
This is what depends. But I mean, if you take a basic, low frequency radio, you can, transmit around the world. People just put up a mast and you can do that. If you talk standard cellular sites, if we go back to Australia, that had some of the biggest cellular sites in the world. I don't know if they still have. We talked about 200 kilometers for one cell site.
For one base station.
Yeah. Now, if we talk ultra high bandwidth, where the frequency are high and you get a lot of capacity, you're talking maybe hundreds of meters that you reach.
So now we're talking about the density of base stations that is required in order to fill the cellular network with coverage.
Yes. So there are two sets of spectrums in 5G. You talk about sub-6, which is sub-6 gigahertz. So anything below 6 gigahertz is known as sub-6. And then you have that's above, you call that millimeter wave. And the millimeter wave, this is super high capacity. You're talking gigabits and gigabits and gigabits.
This is hardcore. You can send whatever you want, more or less.
Well, today. Somebody will figure out how to use that. They always do, right?
They will send GPT-3 over it.
Yeah. So and that spectrum in the millimeter space, it's symmetric. You can send just as much. You can assign it. If you want to go all up, you go all up. If you want to go all down, you can go all down. Whereas there's still some asymmetry in the sub-6.
So the sub-6 is not completely symmetric.
No.
Okay, so these are trade-offs, I guess, in order to make it work.
Yeah, and the main use case, of course, I mean, in a macro network, in a network that we typically have, I mean, it's the driving force is consumers and smartphones, and so it's optimized for that. But it's become better in the uplink, around 5 times.
And where do you think most B2B companies will live the next 10 years? What use cases are really below 6 and stuff? And is most of us below 6 or whatever you call it?
Initially, yes, because it becomes very challenging. The higher spectrum becomes challenging because the radio waves are so narrow. So they won't go through glass or walls or something.
So they also this part they need to really have good. What do you mean? They don't go through stuff as well.
No, because it's physics, right? So I mean the radio wave, you can probably stop the wave with your hand or with your body, depending on the direction you turn and so forth. So it's very sensitive signal. Where the lower signals, they penetrate the house.
Yeah.
With that. So I mean but if you look at in an office environment, typically, because that's also the emergence with 5G, you're going to have these private networks. So companies will put up their own small base stations at their site. And then you can plan for coverage so that the machines or whatever that's going to use it are not, there's nothing in the way, so they can use that full spectrum. So, I mean, there's a number of use cases. One of the most interesting ones I've heard for millimeter wave is the car manufacturers, because the cars are no longer, a mechanical object. They're the computer on wheels, right? There's an awful lot of software and stuff in them. So when the car manufacturers have assembled, I don't know, where at the assembly point when they're finished, they have maybe 200 cars, and they have a number of systems that they want to download software to. Guess what they want? Super high capacity and super high. So if they had a private 5G network, they could flood these cars and literally within seconds have all the software downloaded.
So there's a simple use case at the end of the assembly line, but you just flood the cars and get them out, ship them out.
So I mean
that will speed up the whole.
Yeah.
That use case for the assembly line is...
Whereas today, maybe where they don't even have wireless, somebody goes with a thing and puts in a plug into every car to download. You can see this is efficiency. But
this is ultimately back to what is the problem you want to solve, and then understand that here we have a very specific flooding cars out of a manufacturing line with data, right? Load them up, boot them up.
Yeah.
Bootstrap the car. Yeah. And you could do that really smart if you knew how to use 5G in this particular context. And then you need to choose exactly what we're talking about here, type of 5G. It all connects back together of good product management.
Yes. And again, at the car manufacturing side, you might want to know where all your fire extinguishers are. Okay. Do you need gigabits of data for that? No, you probably just need a simple sensor that sends, once a day, this is where I am. Because when a fire breaks out in the factory, you want something to pop up there. This is where the fire extinguishers are. That's a low bandwidth application, and they have to work side by side. And there are different products that you put in and integrate and do, but they have to work as a whole.
But okay, so we have now explored a little bit like IoT into 5G. We see how the different business case, and we understand that 5G is now actually you need to peel the onion at least one level to understand what types of 5G you're talking about. That's how 5G works. Now comes the really important question. What's the point of all this? What are we going to use the data for? Or what's your view of this? All right. You talk about being the plumbing. Let's talk about, and then smart plumbing. Let's talk about that. But let's move that conversation into also what does this mean in terms of what we're going to use the data for? And, so let's go, because I think this is the topic, right? We have these enablers now, but how does it all play out in the data world? What is your thoughts here?
Well, here you can see, if you build with 5G, with the speeds and the coverage and that, you're starting to end up in a situation where it's just as reliable as a cable, and in terms of latency and reliability, if you're literally as good as a cable, then you can start thinking. You can start thinking about, okay, so what does that mean? Does that mean do I need to really send all the data to the cloud? You could put, there's a trend of emerging that you probably also in the AI space of what we call edge computing. So, but I mean, if you have the reliability out at the edge, why not build a small data center at the edge? Because you have 5G and you have those capabilities, and do the processing closer to the application rather than have to send large amounts of data into the cloud and then the results back. Why? You start seeing that you have other types of use cases and that you can actually do more using 5G because of the attributes it brings to you.
All right. So really make the point. We have a new theme here, and we're talking about now how does this open up what we want to use the data for, and that it really also brings a whole discussion on both micro and macro level to really understand the whole what the data is. So let's say that now, because so let's see if I understand it right. So with this way of thinking and this much more data, it also means we need to start thinking about what do we manage and actually analyze and structure at the edge versus the central piece. So let's start here. What's the edge use cases that you're thinking about right now? Like you're saying, there are new ways of doing it, or there are new use cases. What are those on the edge you see?
Well, let me give you an example that I've thought a lot about. So I mean, if cameras, video generates a lot of data, right? Mm-hmm. So the traditional way would be, you have security cameras, they're connected. Cable,
CCTV stuff.
Yeah, CCTV or anywhere. Could be cable, could be wireless, doesn't really matter. But you send it to a central point and you do the crunching there. You're looking for faces, or you're looking for objects in the picture and that. But what if you can move that instead? If you have thousands of cameras, you're starting to see, wow, you're going to get, if you have video stream all the time, that's a lot of data. And that's a lot of crunching to do centrally as well. But do you really need to do that? Can you make smaller sort of at the edge, that you do this distinction there, that you connect fewer clusters of camera at an edge, and you do the smarts already out there, or some of it, so that you filter away. Say I'm in the camera stream, in the video streams, I'm looking for cats, classic, AI. So it only feeds back pictures or frames where cats are. So on the first
sorting could be done even at the edge, and then you have the first filtering is done there.
Yeah.
The first categorizing and sorting is done at the edge, and then you have a more sharp set to continue with centrally as an example.
For example, so that you only get the frames or the pictures or whatever you want of the cats, and those get sent. You don't get it all, but then you get all the cats from all these cameras, and then you do whatever modeling you do then on the cats. But to pick out the cats, you do at the edge. So, I mean, now you're reducing data and that you're sending backwards and forwards of in the network, which is, an efficiency, because, I mean, somebody has to pay for that data to get sent, because it's not free sending that data. So, I mean, this is a way how you can optimize your operation by not necessarily sending what you need. Or I would think it'd be more a practical use case is that if something happens, then you send a video stream, for instance. If a certain event that would trigger, well, then we do send it up centrally, but otherwise we just monitor and
but because what I need to relate what you're saying now with one of the other guests we had here a couple of weeks back, Lars Albertsson, who is like a guru on data ops, and who really starts talking about the data factory and how do we build a structured data pipelines, and how do we build it in such a way that each set of what we're doing is immutable, so you can share it and you can use it for many purposes. So what you're actually highlighting here is the same kind of thinking, but we actually need to think carefully where does the data pipeline start. And it actually starts by the sensor, and it maybe starts with one part of the pipeline is doing something at the edge, And then it continues more logically here. So it fits really well with the data ops, data factory, data product type thinking, where we truly understand what's the purpose of this data product. Well, the data product at the edge has a very clear purpose. Let's sort out all cats. Super simple, but it has a clear purpose, and it does that. It means a lot. You have simplified a lot by thinking like that, rather than doing everything at the end. So I really wanted to connect with that. Is that the same kind of thinking? So because this thinking has started to emerge in the central systems, right? How do we build data pipelines, and how do we scale? It's vertical scaling end to end. From the sensor to the AI service recommendation. Horizontal scaling. Tons of pipelines that's doing different jobs, right? Now it gets tricky. And all of a sudden now, to think about these topics becomes quite important, and actually the edge open up how you view your whole pipeline. That's what you said. I'm trying to internalize what you said right now.
Yeah, so it's some sort of optimization of the network.
And the ways you flow, the data flows.
Yeah, I mean, compared to my 15 or 14 stop Australia trip, does it make sense to, hop around like this? I mean, ideally, I would go Stockholm, Timisoara, Melbourne, right?
Yes.
Right? Not, all the intermediate steps, but I mean, a little bit the same here. Do we want to pipe everything, fit for purpose? Look at what we're doing. What is it that we're interested in centrally? What is it we're interested in locally? I mean, for some data, it might make perfect sense. Put it all central. For some data, it's not. So, I mean, this is again, the person that's in charge of the data and on what he wants to do with it. He needs to know that and be clear on his purpose. What does he want to do?
What do you want to do with the data? And that topic now is not so simple anymore, because it's you actually to answer that question perfectly well. You actually need to understand what's the end consumption, what's the use case of some sort of, even if it's a customer or an internal customer. And then you have a bunch of stages here. So when you want to define what you want to use the data for, you need to understand it the whole way through the value chain, I guess, or the pipeline. Do you see what I mean, right?
Yeah.
So you need to be quite sharp in defining what do you want to use the data for. I can ask that question for the end game, but maybe I need to then break it down into what do I need to use the data for here, what I need to use the data for here, and then basically you get to what do I need to do with the data at the edge, right? And so what do you want to use the data for becomes one of the most important questions of the future. You see what I mean? Like that fundamental simple question opens up everything, like from the business case, the use case of the customer, to actually what do we need to design for the data to flow, and what technologies to use. And I think this is a huge problem, right? Because the guys who have the business problem don't have the data literacy to understand what do we use, what's the, another way of putting it, what's the data manipulation, what's the algorithm models we need to, I want to use the data for a CNN AI network. Boom. Go step, data scientist. I need to go back a step. What do I need to use the data for? I need to use the data in order to create a training data set on cats. Go back a step. I'm to the edge. I need to use the data to sort cats. Right?
Yep.
It's the same fundamental question, but you need to be able to answer it through the whole chain.
The chain, because I mean, you'll probably have, local, regional, and central storage, and they
all this.
And they perform different functions. And the problem with data probably at these endpoints is that the endpoints aren't specific. So you probably don't have a camera looking specifically for cats. There's probably a lot of other information. So depending on what you're looking for, some is at the edge, some is somewhere else, and some is in a third location.
So, we're joking about, we need to have some cool T-shirts, right? Some good quotes, right? So we have like first principle, like the favorite quote of Elon Musk. And here we have a new quote for a T-shirt. what you're going to use the data for?
Yeah, I mean, literally,
what the fuck is the data all about?
Yeah,
what are you going to use it for? That, ask you that question 4 times, like Lean Kaizen Toyota way. Yeah. What are you going to use the data for? Here. That's a very simple advice, by the way.
Yeah, but I think the problem is that it's early days, and I mean, most people don't know what they want to do with the data. We're stuck. I mean, a lot of early use cases is like it's maintenance, reducing sending manual people out to monitoring and remote maintenance upgrades, that type of thing. But I mean, it quickly evolves that it's so much more, right? So you get so much more information that to enhance your products and whatnot, and you combine data from different points together, and that's how you build value. That's this.
But let me ask you the cynical question then. Okay, so you're at Sierra and you work at the furthest left of this. What you're going to use the data for? On the plumbing side,
yeah,
you're the smart plumbing guy. So I wonder, how many times do you have actually good conversations with the customer when you ask the customer what are you going to use the data for, that goes beyond one step? How many times? Is the customer mature? Can you do the conversation the whole way, or is that the whole problem? Right, that the guys that you are dealing with, they don't have a fucking clue around the domain case.
No. I mean,
I'm insinuating, but what's the real deal?
You're insinuating. I mean, the data question gets asked higher up in the hierarchy, right? So I mean, the people we typically thought, there'll be some engineering department or somebody that's tasked.
I need to connect data. That's all they told me.
That's all they told. So he has no idea. He just
no fucking idea.
He has no idea. He's just, this thing I've got. I don't know anything about wireless, but I know, it's remote. I don't want to send my guy there anymore to do these readouts or whatever. It's not efficient. I want to read all these things and collect all this. But what I'm going to do with that, that's not my job.
That's not my job.
And he has no idea.
It's sad, but it's traditional, right? So we are working super, super techie, and we have a job to take care of infrastructure, right? It's not our job to understand what the infrastructure should provide, right? And here we get into the whole understanding of, is our organization geared for this, right? Like here we have the business processes, the domain knowledge to the right, and then we go into process, and then we go into IT demand, going into the IT supply, from IT supply going to infra, data center, going down to the plumbing, right? And these guys, their job, the way we've been organized within IT and these kind of things, not necessarily have we been cross-functionally organized, but we have our very, I think it goes all the way back to the tech, and the data is not part of the core business as it has been seen as the plumbing. And actually now you need to care about the plumbing to do a data product. That's what I get out of this.
Yeah, you have to care about plumbing. I mean, how happy are you on a Friday evening when your plumbing breaks down and nobody can use the toilets? I mean, it's a disaster. I mean, plumbing is essential, but you don't know how it works. You don't have to know how it works. You just, it works, and it's the same here. So you have, it's a utility, and it's really the same as I've said to you when we've spoken on other occasions. It's like it's your desktop computers and things like that. It's a utility, and it's an enabler for the business, but it's not connected to the business. And the people that typically maintain and do that, they have no idea of what the business is that we sit and program and do stuff on our computers that create value, and we sell something. An IT department, they're not there. We're here to make sure that your computer works. And this is
the same thing, right? And because I think this is one of the hard things to understand now, that you kind of you need to talk about the verticalization of data in some ways here. And there are cases here of some companies who does this better than others. We've talked and we talked about it with Mikael Klingvall, who has been a big fan of Tesla, right? So Tesla has, I don't know how they do it, but how they have a data verticalization happening from the sensors in the car to how they like bring it all together, how the models learn, and then they shoot it out. But actually, it drives also. It is, you know, in some ways it connects the whole way up. The whole vertical chain makes sense, right? It's quite amazing. So I think this is bringing a topic that, you know, you need to master the why the data question really, really well, you know, and it becomes clear when we have AI guests, they ask the same question, right? But they're asking, is this a neural network? Is this a CNN network? Or is it a transformer type style network I'm setting up? You know, same question, right? But at a different level of the stack. So the data scientist has exactly the same question as you have, but for different purpose.
Yeah, different purpose, and it's. I mean, the example you say. I mean, I think the data first companies they grew up with data. So
Yes.
so IT and data are an integral part not only of their product but in how they work
And how they think and how they ask the question. The why the data question comes naturally to them.
Exactly. And if you have companies that are eons old that started with, you know, handmade tools and, you know,
Data is a byproduct.
data is something that has come afterwards, and to get the mindset around. I mean, even in Ericsson, I mean, you know, they put AI into self-organize the networks. That's part of 5G. You know, there's a lot of smarts, but does AI drive their business? Is how they perform their business and how they organize and execute? That is probably not part of their business, but it's part of their product. And I think a lot of companies that even do high-tech products and are in this world, they don't drive their business that way because they have a legacy. They came from somewhere else, and they can build the products with great capabilities using this new tool set, but they can't get their organization to be part of that.
And so, I mean, like, so it becomes the bottom line summary is a t-shirt slogan. What the fuck you going to use the data for? And ask that 4 times. I mean, like that's really driving the whole story here. And it resonates. Now we're talking IoT and you ask the same question, right? And then we need to also ask it the whole way through, all the way up to the AI and all that. So, I mean, like, we're running out of time now, and I have 2 major topics I kind of want to cover. So I think that's a wrap on that topic. I want to talk a little bit about the whole transformation about going, you know, and I think because you are experiencing, you're in the heart of this transformation, right? From hardware to software, from one-off projects to recurring revenues. So, like, we talk about the word digital transformation, but I think let's talk about this fundamental shift that is happening in many industries now. And I think the data and AI readiness revolution is also about, you know, we have all these fantastic analog customers that now need to have data and AI services and products. So I want to explore this from the Sierra angle. You know, you are coming from hardcore wireless, you know, gizmo player, and you are now talking about a different offering where you have your carrier stuff and you have your, you know, there's different things. So what do you think about that whole journey from hardware to a service and one deals to recurring revenue, stuff like this?
Well, I think, you know, it's a journey I think most companies will need to jump on at some point. And I mean,
why is it for all? You know, why do we all end up here? I just want to challenge you before you go down that's a good train.
Well, that's a good question. But I think, you know, at the end of the day, the recurring revenue model is a preferred because you even out, and it has to do with. I think it has to do with the, you know, stock markets and you know, we tie into that, you know, you have to perform well every quarter. I mean, if you do one-shot sales, you might have, you know, a fantastic Q1. You sell 230% of what you did, you know, Q1 the year before. But But in Q2, you're down to 70% of the year before, and then
But I think this is good. But I think it's also part of what position do you want to have in the value chain. I remember from the product lifecycle management, stuff we did with Ericsson, we talked about, okay, if we are the commodity and the customer wants the service, we are actually opening up that there will be an other guy in the middle here. And I remember we were talking, this is 2005 or something like that. And we could already then see that, okay, if we only stay on the hardware, someone else will figure out, the hardware is not the real value. The value is actually how I provide, in this case, data to their data center. And the problem that you're solving that is of value is also so what I think it's the recurring revenue is also a consequence of where you want to do in the value chain. Some people can say, I want to stay, I just want to produce chipsets. That's all I want to do. But the customer is not wanting chipsets anymore. It's also the customer, everything gets more complex. And the end customer don't want to deal with that complexity anymore. So they want to manage service. They want something else.
Yes.
And all of a sudden, are you going to take that position or not?
Well,
I think that's part of this game as well.
Yeah, well, partially, the Sierra position, that's partially the Sierra position, right? So, we had hardware, then, you have to manage the hardware. So you have the management piece of the hardware, and then you have the connectivity. And if you have to go, it's really like, a PC in the early days of PC, you bought different parts from different providers and you built it all together. And that's fine, maybe on a small scale. But if you want to scale that, you don't want to do that every time. You want a complete computer every time. I just want to go to my guy and I get everything and it works. So
I think that's the game, right? So the game is also basically the customer wants something else and the hardware and figure all the shit out. It's too complex.
Yeah, because at the end of the day, a business wants to spend their time figuring out, how do I do value in my business? I don't want to learn another industry and what it makes to, build these gadgets together.
I don't want to deal with 70 carriers.
Exactly, it's making the hard simpler. You buy a part of that, and as you say, it might not be for everybody, but I think it's getting there to more for everybody. So and also the thing is that if you draw that even further out, well, I only want to pay for it while I use it. So you can start measuring. Well, I use it 16 hours a day. The 8 hours a day I don't use it, I'm not paying for it, but I'm willing to pay this price for when I use it. And those models will also occur. And seeing, typically, the connectivity part is, it's about bits and bytes. So that's typically, usage based,
But your main bet is that people don't want to end up with the complexity of managing the sensor and all this, and then dealing with all the carriers. So you're betting on what they really want. What the value is the data stream.
Yes.
And then how can we build? And that's our problem to fix.
Yeah.
Something like this, right?
So the plumbing of it, I just wanted to. I want data from A to B, and really how it gets.
So you don't
there.
center on the component anymore. You center on the core oil.
Yeah.
The goal is data, and how do I get that from the sensor to here?
Yeah.
That becomes the core business.
Yeah, and but it's also, I think the challenging there is the conversation. Who do you have that conversation with? Because that's typically not an engineer, right? So the engineer built the sensor and the stuff that went to it. He's like, I have data, I don't know what I'm going to use the data for. I just build stuff, right?
So your whole conversation, that's typical now. So the point of how to sell changes.
Yes.
So how is Sierra coping with that change?
I mean, it's been a journey, and we're starting to get there. And I mean, it's an educational from everybody. And with acquisitions, we've had people come on board that come from the other side that are used to selling services. And then we say, now we're combining it with hardware. And then they go hardware, what?
Protocols, what?
Yeah, and hardware is a long sales cycle. A service, once, you've checked all the boxes, you go, great, I'll have that service and, you're up and going. hardware, you need to integrate, you need to test, and you need to figure out some more stuff. It takes forever.
So some of your fundamental processes is geared for the hardware sale, and that need to be rethought how it works now when it's a service sale.
Yeah, and I mean, and people need to be geared, and it takes time. I mean, it's hard to change people and people's habits, and it's a new set of skills, and everybody has to get on board. And I think we've done an interesting journey, and we've had a clear direction of going more into the service space.
But I think there's another angle on this, which is similar. The hardware topic becomes a software topic. I mean, like if I talk, if we would look into a radio base station of Ericsson in the 90s, and I would do a measurement, how much percentage is hardware versus software, and then I do the same measurement on a cellular base station of 5G,
Yeah, there's still a lot of hardware, but the value isn't in the hardware. It's as you say, it's in the software. What can I do with the hardware?
I mean, like also embedded now is a lot of software going on in the actual product.
Yes, and I mean it's and then you can pick and choose. Do I want to use feature A, B, C, D, or I mean it's the same here. For us, you don't have to use our service. You can pick and choose. Well, I want to manage this part. Yeah, fine. I want the hardware or that, or I want the whole thing. So it really depends where you are at and where your focus is. So, I mean, if you're still focused, as you said, on the gizmos, you can continue to do that. And I mean, there will be some that continue that forever and be very successful, and we can still serve them. But I think the paradigm shift of where everybody wants to get the data and they get less interested in, the gizmo, I just want my data and I want you to help me get the data, and I don't really care what's there.
But I think in some ways also, like the journey you are talking about now, let's connect it back to the whole world, because when I was at Vattenfall, and now I'm working a lot with Scania, and I think, and it becomes clear for me, for these sort of big companies, whatever they have done as their super successful legacy as an analog company, they are essentially turning into 50% software companies, whether they like it or not. I mean, like the next level of efficiency in managing an energy network is not going to be the copper anymore. It's going to be the software and the optimization of the net. And the next level of truck manufacturing is going to be a transport ecosystem. We talk about this already. So essentially now, two companies I work with, which has a 100-year-old legacy, hardcore physical assets, whatever they do. But the paradigm shift, even if it hasn't really fully happened, everybody knows it. That whether you like it or not, in 10 years' time, 5 years' time, we are 50% a software company. So I think the whole idea now, this transformation we're happening from, and then of course, Scania is also a service, right? We got to measure and we're going to pay for transportation. Autonomous vehicles is one step, and then actually who's going to buy a vehicle? It's going to be all, routed around. If you think all the way out where this goes, so I think to close off, or like like this topic of sort of how to do this topic, which was all about like digital transformation, where this is going, data from products to service, or from hardware to software. I think the end note, where I want to go the last couple of minutes on this is sort of, if I now take this conversation we're having, and then we are saying something that we said before, everything is going to be connected. Okay, connecting everything, like the 50 billion connections of IoT of Ericsson or whatever. And then we now take a data and AI first mindset, right? That's sort of the end theme.
The end game.
The end game is quite. I don't think it's quite. it's not rocket science to see where when you connect everything and you couple that with the data and AI first mindset, it kind of means we're all software companies, or we all need to deal with data regardless of what process we are in, right? That I think that has to be super, super clear to everyone by now.
Yeah, and I think you're absolutely right, because I mean, it doesn't really matter. I mean, the way we can see it, you know, as you say, analog things. I mean, you know, because we connect things. I mean, the types of applications we see, you know, it's none excluded. It could be, you know, you have warehouses, you have problems with rats. We connect rat traps that send an indication when they've killed a rat. I mean, there you have it. The warehouses, there are no lights because nobody works in the warehouse. They're completely dark, but you know, so they have sensors.
Yeah, and Walmart have sensors on their cans of soups in order to understand stock take in real time.
Exactly. And
so it's just a matter of what type of sensor fits this type of business problem and cost.
We have the agricultural industry that you think would be very basic, you know, food production, but you know,
I saw the Huawei case when they connected cows. Have you seen that?
Yeah, connected cows. That's no one, but I can give you another one. You know, they're starting to put sensors in the ground to see, you know, when the optimal time is to harvest. When you know the humidity, temperature, or whatever, exactly. you know. So I mean, it is data. It doesn't, you know, you're not isolated unless you go off grid, literally. If you choose an off grid, but I mean, you know, you're not, you know, you're a decimal somewhere in that, you know, the mountain men in Alaska or whatever, that, you know, they're off grid.
Then you're off grid. But for the rest of us who's following the trajectory, I mean, like this is some sort of trajectory. Yes. If you're a farmer, you kind of need to know your data and AI around when to harvest your crops, for sure. Yeah. The sensor is there, the AI is there. The use case is there. Yeah,
you know, fertilize, whatever. You know, there's poor rain. I need to water. You know, it's data. It's all about the data. Data is the currency, and everybody needs it.
But okay, so as an ending note, so if we sort of see this sort of, we all become sort of software companies, and we have algorithms supporting every single process that we can think of. If we know that already now, and we kind of want to do the right stuff now, take the right choices now, today, tomorrow. So, you know, what do I do as an organization, public sector, private sector? You know, what should I focus on now? Because I guess I'm so far away to have it all lined up like that, and I don't really know how the infrastructure will work. But what are things that are sort of no regrets stuff? Do it anyway, because it will help you accelerate this journey. What do you think that is as an ending note?
Well, yeah, I think the ending note is that as I said, you know, no organization started big, everything started small. So I mean, to get started, you need to get started, get your hands dirty, you know, try, you know, small scale, you know, what does it mean? Connect one thing and see, what does that data tell me? What data am I getting? Is it, you know, can I use this for something, or is it something else? Rather than go, we have to change our whole organization. We need all these systems. No, I mean, that's the wrong approach. You have to start small.
So everybody needs to understand that where even the Amazon started small, right?
Yes.
I mean, like even the Amazon started in the garage. And the tricky part is for our big corporations or the public sector to come into that mindset to basically not overdo it, but just learn. And it's a learning curve. That's what you're saying somewhere. And
it's you know, those simple things. Start connecting your things and look at the data. You know, you need somebody who does. And it's multidisciplinary, as we've said.
You need to start figuring out the multidisciplinary thing. Yeah. Get on that. Okay, so start small. Just get started, so you get more concrete understanding, and then this will be multidisciplinary. You cannot fail when you start to putting the right brains together with different perspectives on this in order to cover the value chain, literally.
Yeah.
That is a no given, get on that bandwagon now, yeah? Please.
Yeah.
Then I have one more for you.
Oh.
Start treating data as an asset. If you think and say data is the new oil, you can't treat it as a byproduct. If we all understand now that all this will be driven by data, but it means that we need to have classified it, categorized it. We need to have put it in a catalog. Otherwise, why are you collecting all the data if you can't find it and use it and understand what it is? So whether you like it for the short-term game or the long-term game, start small, cross-disciplinary, start caring about the boring data stuff, not treating it as a byproduct.
Yeah.
Those are 3 good advices.
Yeah. I mean, data. Don't forget the data.
Don't forget the data. All right. So we are basically over time now. So last question to sort of kind of wrap this up. I have 2 questions for you. Number 1, what's next in your life, or what is sort of cool stuff on the horizon that you're working on, or privately in the Corona time? I don't know.
I don't know. I'm really looking forward to 5G because it's the big new thing is a B2B play.
Do you have some? I'm sure you have some interesting conversations going on now that you can't talk.
Yeah, absolutely.
Some cool stuff. Yeah.
Yeah. And I think that's the game changer for me. That the excitement, the hype about 5G isn't about the phones. It's going to be the industry.
This is an industry play, really.
Yes,
okay, cool.
That's the cool thing.
Cool. And now, very last question: if you would recommend, or who would you want to listen to on this podcast? I'll put you on the spot now. So if you think about it, like which is your dream guest you want to hear that we can get, you think? Any cool guys that you want to listen to?
That's a hard one. Well, Ray Kurzweil, but I doubt you get him. But I mean,
it's good. We will try. But okay, so make it on Earth. Ray Kurzweil would be super cool. But any colleagues, any good cool customers, anyone, it's the data and AI connection we're looking for, of course. But also in industry or politicians.
Yeah, I was thinking about that. Who's really
who regulates 5G, by the way?
In the country, it'll be in Sweden. It's PTS, right?
PTS, right?
It gives their license.
Someone from PTS would be interesting.
If I would say, I'm not sure who to pick, but I think the conversation I would like to see in data and AI, because it's supposed to benefit us as people.
Yes.
And then I think public sector. I think people from public sector, somebody who understands this and on a mission really to change this, because I'm desperately afraid that
public sector is
left behind and doesn't get it. And the question is, will they ever get it? And what happens then?
Yeah, and I mean, like, in Sweden has a quite. I mean, like in our GDP, Sweden is a country with a quite high percentage in the public sector. So it's so this is for the whole country, right? So public sector view on data and AI is something you look for, and guests in that area.
Yeah, and how they need to embrace and work to use that tool to become a better society.
So we had Louise Kallenberg, who is head of digitalization in Esquire. So, but let's take some more people from public sector. I like that as a summary,
because I think
that's important for society in Sweden. Yeah.
Thank you, Henrik.
Thank you, Daniel. Super cool. Thank you very much for this excellent journey. And 2 hours flies, right?
Right. Yeah, I'm surprised.
Yeah. Take care, man.
Thanks.
Thank you.
Thanks, man.
Bye-bye.
Bye.